I'll start my presentation with the fabrication with computer vision. Now, I'll explain motivation. Scene is generation in the process of forest management and seeing it is not easy to utilize, and much of it is left in the forest and overstocked because the wood from seeing is small in diameter or crooked. Overstocking increases the risk of tree disease, insect damage, and wildfire. The wood from seeing is small in diameter. When it is sown, almost all the usable parts are gone. Therefore, we have developed a technology to process the wood without sowing. There have been cases of direct processing of logs before our study. And most of log processing systems do not allow free repositioning. This is because if the posture of the workpiece during machining is different from when the shape is measured, the difference in posture needs it to be handled, and measurement of posture change is not easy. In this case, the posture is tracked by attaching a jig to logs, which enable machining with different postures. However, in this case, it is necessary to prepare as many jigs as there are logs, and there is problem that the jigs themselves become too obstacles to machining. These jigs. In this study, we have developed a method to estimate the position and orientation of the logs and process it without jigs. This is workflow for the effective use of the developed processing system. The database stores information such as logs, shapes, and IDs like this. We designed build this staircase to check the availability of the workflow. On the right image, the shape of the log stored in the database is applied to staircase members. This is the stringer part in the staircase. It needs to be machined from the top, bottom, and side. It is shaped in that it is difficult to machine in one position. By showing the machine process of this part, I will explain the detail of the proposed workflow. This is the self-made processing machine we used in this research. This machine is a gantry type machine with 3 linear axes and 2 rotary axes. This machine is equipped with a camera for position and orientation estimation. The camera is not special one, but an ordinary RGB camera. It is necessary to measure the position and orientation of this camera to estimate the position and orientation estimation. The position and orientation estimation of the camera is estimated by solving the perspective and points problem. Perspective and points is corresponding point in 3 dimensions and 2 dimensions. This method estimates the position and orientation of the camera from the combination of the 3-dimensional coordinate of the points and the project 2-dimensional coordinates. We estimate position and orientation of the camera by making combination with the coordinate of machine controller and the 2 chip. Now let's talk about photogrammetry. Photogrammetry is a technique to obtain the shape of an object by photographing it from various angles. Photogrammetry is technique. photogrammetry actually generates not only the shape data, but also position of the camera that to the picture and 3D coordinates of the image features when picture was taken. Now, this data is used to improve the accuracy of the photogrammetry and to estimate log's position and orientation. Now, photogrammetry has a problem, a low accuracy scale. So here is alcohol used in research. Taking a picture of alcohol gives us exact distance between the cameras. So matching linear camera distance obtained by photogrammetry with inter-camera distance obtained by the alcohol will improve accuracy of the photogrammetry scale. The method of generating the processing path is the same as normal one, but coordinate system of the processing path is tied to coordinate system of the shape data. The method estimates in the position and orientation after preposition can simplify the preposition tools. In this experiment, only 2 toggle biases were used. No special jigs were used. Camera capture a fixed log. We acquired image feature from the image. By matching these features with photogrammetric features, solving PNP problem at the corresponding points, we can obtain the camera coordinates in the shape data coordinate system. Now we can go back to from the model coordinate to the camera coordinate system, and from camera coordinate system to the machine coordinate system. This is used to convert the model and process path to the machine coordinate systems. This is result on projecting the estimated log model onto the camera image. Now the estimation is done, and we have processed it. Here is a picture of being processed. In the case of this part, it was repositioned 3 times, and the estimation was successful 3 times. The image on the left showed the location of the match image featured during the estimation process. Experimentally, estimation is successful when more than 25 points are matched. This is the result of machining. It's the details of the parts after processing. This is the result of combining the parts. This case is used in our laboratory. The conclusion. We have confirmed that proposed workflow can be used to process logs without jigs. Then this method uses image features of the log surface. If there are many places that have lost their features due to processing, the estimation cannot be done. The next step is obtain new image features from the new surface created by that processing. The method itself can be applied to other materials such as stone, as long as the material can be acquired image features. We will try other materials in the future. Thank you for listening.
Thank you so much, Genki, for your